All right, guys, so now we're bouncing back to triangles, and not just any triangles, right triangles. So remember, a right triangle has one 90-degree angle, and then the other two are going to make up the other 90 degrees. So what we have here is the Pythagorean theorem. So Pythagorean theorem, basically in technical terms, says that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So it's really important that you kind of sort of have this vocabulary to know how to move forward. So you'll probably recall, I think from 8th grade, is probably where you saw it last, is a squared plus b squared equals c squared. And a lot of people remember Pythagorean theorem, a squared plus b squared equals c squared, even like after they've left high school. So a squared plus b squared equals c squared is just where you're going to say the leg, which is a or b, doesn't matter, plus the other leg, the other side. Okay, the two legs make up the 90-degree angle, and then the hypotenuse is always c, and it's always directly across from the right angle. Okay, so the leg, you can name it A or B or any other letter, basically, but the C always has to be the hypotenuse, which is that slanted side, which is across from the 90-degree angle. So let's take a look at this, and you'll probably just have to recall back the Pythagorean theorem. So what we're going to do here, the first problem here, we are going to find the missing side length. That's what we're going to do for all of them. So trying to find the missing side length, I need to figure out, is this a leg or is this a hypotenuse? That's the first thing you need to decide. Well, since it's the side that's across from the right angle, that's going to make it the hypotenuse, which is going to be C. So I know that Pythagorean theorem says a squared plus b squared equals c squared. And I know that it's c that I don't know. So 12 can be a and 5 can be b, or you can switch those. It's not going to really matter. So I'll have a squared, which is 12 squared, not times 2, 12 squared, plus b squared, which is 5 squared, is equal to c squared. And so then I'll take 12 squared, that's going to be 144, plus 5 squared, which is 25, is going to be equal to c squared. And so 144 plus 125 is 169, is equal to c squared. And then the last thing, to undo the squared part, you're going to find the square root. So when you take the square root of 169, that's going to be 13, is equal to c. So the third side is going to be 13. So that's not a rounded number, that's exact, because 169 is a perfect square. When you take the square root of 169, it gives you a nice, pretty number, 13. All right, so let's look at this second example here. So again, the first thing I need to decide, is it the leg or is it the hypotenuse that I'm solving for? Well, since across from the right angle, I have a number that's not my missing side, then this is always going to be C, so I'm solving for one of my legs. So therefore, I'm going to have one of this A or B, it doesn't matter. So I'll call this A, and 9 is going to be B, and C is going to be 15. So based on the Pythagorean theorem, I'm going to have A squared plus B squared is equal to C squared. And so therefore I have A squared. I don't know what A squared is because I don't know A. Plus B squared, which is 9 squared, is equal to 15 squared. And so then squaring those two numbers, I'm going to have A squared plus 81 is equal to 225. That's what, when we take 15 squared, that's what we get. Then to get A squared, so this is like just going back to solving equations, I'm going to subtract 81 from each side. And so I get 144 is equal to A squared. to undo the squared part, okay, that's going to be taking the square root. Just like I have to like subtract or divide or whatever I do to get rid of stuff with my variable, I have to do the same thing with a squared. I have to take the square root. So I have A is equal to the square root of 144, which is a nice, pretty number, and that's 12. Let me 12 centimeters. I don't think I labeled the last one. So A is going to end up being 12 centimeters. I didn't write that. Centimeters on the first one. All right, so let's look here. We're going to find another missing side length. And so that I have to just determine, is it the hypotenuse or is it a leg? So since I'm going to look across from the right angle and I have a value there, that's going to be C. I'm solving for a leg. So this is going to be A or B. It doesn't matter. I'm going to call it A. I'm going to call this one B. I just like that a little bit better. So I'm going to have A squared plus B squared equals C squared. That's the Pythagorean theorem. I'm going to have A squared. I don't know what A squared is. Plus B squared. B is 10 squared is equal to C squared, which is 26 squared. Then I have A squared plus 100 is going to be equal to 676. And then again, solving for A, I'm going to have to subtract 100 to get rid of the 100 that's with A squared is equal to 576. And then I'm going to take the square root of each side. And so A is going to be equal to 24 centimeters. We're going to take the square root. It's a nice, pretty number. So A is going to be 24 centimeters on this side. All right, so now let's look at this one. This one's a little bit trickier because we're trying to find the value of the x. So what you want to do, like just intuitively, when you're trying to solve this, you think, hey, I'm going to include that side in my Pythagorean theorem. You're thinking, oh gosh, that's going to be a lot. And it is. So if you'll notice, I have another side that I'm not using. So what I could do is I could say this whole side is something that I don't know, which is, it makes it the right angle. So this is going to be A, 16 is going to be B, and 20 across from the right angle is going to be C. So I'm going to call x plus 9 A, because I want to find out that whole length, and then I'll figure it out from there. So if I know the whole length, then I can figure out what x is from there. That makes sense? So I have A squared plus 16 squared is equal to 20 squared. So A squared plus 256 is equal to 400. And then again, I'm solving for a leg, so I'll have to subtract 256. And so therefore I have A squared is equal to 144. So then I'll take the square root of each side, and A is equal to 12. And so therefore, I know the whole side length is 12. And so I also know that that's equal to x plus 9. I'm trying to solve for x here. So I'll subtract 9 from each side. And so 3 is equal to x. Even though A was 12, that whole side length was 12, it's asking me for x there. So you'll have to solve the Pythagorean theorem and then solve for x. So it's just a little extra step there. But just kind of trying to stretch your brain and think about Pythagorean theorem in different ways. So again, Pythagorean theorem, A squared plus B squared equals C squared. Step 1, figure out, are you solving for the hypotenuse or the side or one of the legs, and then plug it into the Pythagorean theorem. You'll have to square and then take some square roots. That's again where the simplifying radicals part comes in, because you may have to simplify the radical looking at answer choices to pick the correct answer. And so that's it for Pythagorean theorem, and we're going to look some more at this couple more lessons. But it's now time for you to practice with your skill check.